Hi, today we're going to review limits from pre-cal. Before we go into the problems that I assigned to you guys for the homework and what you need to know for the tests coming up and the quizzes coming up, is we need to kind of review the difference between what's called a value and a limit. We should remember that the value of the function is what the function is. That's our f of x. The limit of a function isn't the value, but it says not where we are at, but what are we approaching. And that's a big difference. It's not, so for example here, if we look at the graph here, if I were to say what is the value at 0, you would say the value is 2, because at 0 we know that the value is 2 on that graph. But now let's say, well, what's the limit as we approach 2? Well, in that case, we are not exactly on 2, but we are on the path that leads to 2. And I mean, from the right. But if you notice from the left, we actually approach 0. And that's kind of the difference right there. Where a value says, where is the function at a particular point? The limit is saying, what is the value we are approaching as we come in from both the left and the right side? And we have a notation for limits. And that notation is very simple. We would say it's the limit as our independent variable approaches some number, like b of the function. And one thing how I like to view a limit as, imagine there's a road right here. And as you're driving along that road, here's your car. As you're driving along the road, your position is the value. That's where you are located. But you're approaching a point. You're approaching a point, and that is your limit. What are we approaching? I'm approaching so-and-so's house. Like you tell your parents, I'm going out. I'm approaching somebody's house. Now, when it also comes to limit, of course, we have our notation, which you should know, but we also have other little notation as well. And if you notice that the examples down here, we have these plus and minuses. And you should be very well aware that if we're approach B from a minus, that minus means we're going to approach a point from the left. Likewise, if we have, as x approaches, let's say some b from the plus side, this means we are approaching from the right-hand side limit. Now, ideally, for the limit to actually exist, they have to be equal. And that's going to be our biggest definition. I do want to write that down here. So for the definition of a limit, and you should remember this from last year, is that for the limit to exist, the left-hand limit has to equal the right-hand limit. And that is humongous for us. It's a very big topic for us, for the limit to exist, and we have to always know that. So let's take a look. So for example, A here, we want to find the limit as we approach 0 from the left. And if we look over here, the minus sign here says we are definitely approaching from the left side. And so that means as we approach x equals 0 from the left, imagine you're on the function and you're driving along that function. From the left, what value are we approaching? It looks like we're approaching a y value of 0. Now, we never reach that 0 because, of course, there's a hole there. But it doesn't mean we can't approach it. So we would say that this is going to be 0. Likewise, so let's say we approach from the right side. Well, from the right side, same idea. I want to get close to it, to 0. Here's x equals 0. But on the right side, here we go, we're moving in the direction towards that 0. But this time, instead of approaching 0, we're approaching a y value of 2. So we're going to put a 2 here. And now we have this one. Now notice for part C, there is no plus or minus there. So Now we're starting to look for what's called the actual limit. And this is where that left and right hand have to be the same. And if you notice, from the left, we're approaching 0. From the right, we're approaching 2. So what's the actual limit here? Well, since they're not the same, we say this limit does not exist. DNE. Please don't say equals DNE. That looks weird. We just say DNE, does not exist. Or my high school girlfriend's name, Denise, because she did not exist. So let's try the next row here. Here, again, we're approaching 2 from the left. So if we approach 2 from the left, it looks like my y value is approaching -2. From the right side, we're approaching 0. So same thing. Because from the left we're approaching -2 and the right we're approaching 0, they're not heading to each other. So we would say that the actual limit, again, for this one, does not exist. DNE. Don't say undefined. Undefined is very unclear. Undefined could be anything from a vertical tangent to all sorts of weird things. Does not exist says it can't be anything. It's just not anything. We can't even come close to defining it because there's just nothing there. All right, let's try 4. All right, here we go. Now this is a tricky one. From the left, if we approach x equals 4, it looks like we're approaching y equals 4. And that's what we're going to put. On the right-hand side, same thing. It looks like we're approaching 4 as well. So I'm going to put a 4 there as well. But now they want the actual limit. Now be careful. The limit does not have to equal the value. And that's very important. The limit does not have to equal the value. I know that the value at 4 does not exist because there is a hole there. There's a hole. But it doesn't mean we can't approach a hole. You can approach the cliff of the Grand Canyon. You just don't want to go in it. So over here, we're approaching 4 because from the left and the right-hand side, because I'm approaching 4 from the left and 4 from the right, the actual limit this time is going to be 4. And that's how we solve these. So let's practice. And that's how we work limits from a graph. So now let's take a look at them algebraically, especially how we want them in calculus. This becomes a little bit more important for us, okay? All right. So here we're given 2 graphs, F and G. And for the first one, we want to find out, well, what's the limit as x approaches 2 from the right of f of x plus g of x? Well, here's f of x, here's g of x. So the first thing we're going to have to do, and you're not going to like this, is we have to actually split this up. We have to write this as the limit as x approaches 2 from the right of f of x plus the limit as x approaches 2 from the right of g of x. Not probably something you did in pre-cal last year, but in calculus, we have to show this, especially if you're taking the AP Calculus exam. And now we're just going to take a look. We're only interested in the right side. Here's x equals 2. From the right side, f of x looks like it's approaching 3. So I can say that this is 3 plus. Now g of x, same thing, here's 2. But be careful, the actual limit does not exist. But from the plus side, the right side, it looks like we're approaching 5. So I'm going to put 3 plus 5, and that's going to give me 8. Part B, same thing. We're going to split this up. It's the limit as x approaches 4 of 3 times f of x minus g of x. So I'm going to rewrite this as 3 times the limit as x approaches 4. I can just bring that 3 out. It's just a multiplier. F of x minus the limit as x approaches 4 of g of x. All right, so we can get 3 times, let's take a look here. For f of x, as x approaches 4, it does look like it's approaching from both sides, and it's not a perfect number, so I'm going to make that about 2.5, I guess. So 5 halves, 2.5. Minus, for g of x as we approach 4, let's take a look here. From the left and the right, we are approaching the same number, and it looks to be 2. And we're in luck. In calculus, we're never going to simplify it. You're just going to leave it like that. Do not simplify. That's cool. Matter of fact, for part A, you could have left it as just 3 plus 5 right there. All right, so for part C, splitting it all up, whew, it's almost like we're distributing a limit. It's not technically distributing, but you can kind of think of it that way. Minus the limit as x approaches 4 of f of x over the limit as x approaches 4 of g of x squared. All right, let's kick it. All right, we already actually know what the 4's are. Now, the tricky one is this first one. As we approach 2. Notice 2 is not one of my functions up here. 2 is just always just 2. It's like, this is like saying, look, here's y equals 2. Well, we know what that looks like at 2. It's just a horizontal line. So no matter what, it's always going to be 2. We call that the constant rule. So this is just going to be 2. Oops, that's a weird looking 2. 2 minus f of x, we already know. That was this 5/2 over g of x, which I know which was 2, squared. And again, you can leave it like this if you want. We'll talk more about simplifying these later on, but you can leave it like this. Or just multiply everything by 2, and you get 4 minus 5 over 8. More minus 1/8. All right, so let's write one where the limit does not exist. So that's easy to do. We just want to find out where the left does not equal the right. Keep it simple. I can say the limit as x approaches, let's just do f of x. For f of x is a number of them. I could pick 6 or -2. Now later on, we're going to talk about endpoints as well, but let's just keep it simple for right now. So as x approaches -2, does not exist. But they say explain why. So now we're going to say, normally when it doesn't work, you want to explain why. And that is because, we can get fancy, the limit as x approaches -2 from the left does not equal the limit as x approaches -2 from the right of our function. And that's it. All right. Hope you enjoyed this video. Go on to my next one. I'm going to go over a little bit more. The algebraic ones. Hopefully we should be going to pick up a little bit faster. See you then.